As we continue in the advanced section of the Tabular module in Analysis Services, we're going to look at the calculate statement as well as some time intelligence. First, the calculate function is used to take a table or filter set and apply other DAX functions to produce the desired result. The analytical method that works here is great for Tabular module, and it promotes the centralization of measures in analysis services. The wrapper is for measures only. Do not try to use the calculated column with the calculate statement. Remember, the calculated column is for the row context of data, while these other functions are used with a table or filter in the context of rows of data. Once we find the time-based function needed, we wrap the table or filter context and time function in the calculate statement to create an intelligent measure for end users to slice and dice. Examples of these include year to date, month to date, as well as quarter to date. We can also use a total for all that is displayed and even create a ratio from that. Then you could even use a previous period function to return time-related measures to compare and then get trends whether they are up or down. Eventually, we can use these measures to compare to a target. These key performance indicators, or KPIs, will help the business produce their own measures of success or target areas for improvement. The calculate statement receives an expression and one or more filters. The filters will override any previous user filter context that's used in a reporting tool. The expression has some requirements. It is essentially the same as a measure, like sum of sales amount for internet sales. You cannot use a nested expression. A function used in the expression cannot be used to return a table. The return value or values from the calculate statement is the result from the expression filtered. The ratio is a great example for using the calculate statement. First, we need a total sales column for the denominator of the ratio. This calculation needs to remove any filters because we want the ratio to all. This example starts with the calculate statement followed by the expression internet sales, which is a measure. Then the filters are applied. In this example, the all function is used with the table name as a parameter. We are essentially saying show all rows in the internet sales table while calculating or summing the sales amount for each row. Even though we calculate the total first, we could have embedded that calculate statement in the ratio measure. But here we see the ratio is the measure internet sales divided by that previously created total internet sales. We also need to format this ratio as a percentage in the properties of the measure. We can also hide the total internet sales from the client tools if displaying would confuse or complicate the reporting. The display here is 100% because it has not been sliced or diced by dimensions. Once we view in Excel or another reporting tool and add attributes or hierarchies, it becomes apparent what the ratio looks like. We need Excel or a reporting tool to display the ratio with attributes and hierarchies and seeing the ratio to all percentages. Like in this example, we see that bikes have a total internet sales of 7 million, but total sales over all categories and years is 29 million. That's where we get the 24.10% ratio. So now let's look at a demonstration of using the calculate statement. First, we'll launch SQL Server Data Tools. From there, we're going to open up a previously created solution that already has some of our measures inside. We'll go to File, Open, Project or Solution, enter our tabular model, which is the AdventureWorks DW14 solution. Here, we'll open up the model and go to our Internet Sales tab. From Internet Sales, we should see our previous calculations, like the sum of Internet sales and gross profit margin. We're going to click in one of the empty cells here to create our first calculation. The first one is going to be total Internet sales overall. So we'll type in a name, semicolon equals, and we'll start with the calculate statement. The IntelliSense helps us with the syntax. As I tab out, it's going to ask me for an expression. I'm going to grab the Internet sales, which is a measure of sum of sales. Next, I'm going to put a comma and start with a filter. The filter I want is to override any other filters in this context. So I'll start with the all function, open a parentheses, and now it's going to either ask me for a table name or column name to filter. I'm going to pick the entire table, Internet sales, and close that parentheses for the all function, then close the parentheses for the calculate function. As you see in this example, total Internet sales of all is for all Internet sales no matter what attribute or hierarchy we are using. If, for instance, you wanted something like of a parent of a hierarchy, or even like the category of a product, you can include that in your filter statement by selecting that key column from the fact table. But here we want the all. So I'm going to hit the enter key and it should calculate that for me. Now this is a currency, so I'm going to want to highlight my new measure, go to properties and change the format to currency. Now I'm going to save my work, go to the model menu choice and analyze in Excel. Once Excel comes up, what we're going to need to look at is what that total Internet sales value looks like. So in our pivot table fields, we see our original measure, Internet sales. We also see the measure, total Internet sales of all. So that displays the same amount based on no slicing and dicing. If we scroll down in our pivot table fields and get to year, quarter, month, date, hierarchy, we'll drag that to the rows and we'll see that the total Internet sales stayed at the full total of all sales, but our sum of sales now is broken down by year. And because our date dimension has 2005 through 2009, that's why we get this in this display. So what we might want to do is filter that out for now, pick those years that we want displayed, and we don't want 2009 either, and we'll save that for now and come back to it. We'll minimize Excel and go back to our tabular model. Next, we need to create a ratio. So I'm going to click in another blank area towards the bottom of the table and give this new measure a name. I'm going to say Internet sales ratio to all. Put a semicolon and equals, and now I need my numerator. The numerator is going to be Internet sales, but I need to preface it by a bracket, Internet sales. Then I want to divide that by that total sales. So I'm able to place the two measures in a new calculation. I can actually put the full syntax of those individual calculations in here if I wanted to. But for development purposes, so that you can see the effects of what you're calculating, we placed it as separate columns. I'm going to hit the enter key to accept that calculation, and you'll see the ratio is 1. We really need that to be a percentage, so we'll go to the properties, change general to percentage, and now we have a percentage. But we don't see the percentages divided by the attributes and hierarchy. So I'm going to save this work again and go back to Excel. Now we just need to do a refresh all to pull in our new measure. Once we refresh it, we'll scroll to the top and we'll see internet sales ratio. I'm going to select that measure, and now we can see the percent of each one of those years over the all total internet sales. And if we drill down in 2012, now we see percentages of that year by quarter. Now what I'm going to do is move the values to my rows, and I'm going to scroll down in my list and pick a new hierarchy like products by category and drag it to the columns. Then I'll go ahead and close the pivot table fields and filter out the blank, which actually exists as a category in our cube. I'm going to take that off, and now we see the 0.15% is the internet sales for bikes over all our data. Then we see the 7 million divided by 29 million for 2011 is 24.1%. And we can drill out into bikes and see those percentages as well. Now once an end user starts seeing this, they're going to say, I want a ratio of parent. And that is absolutely doable in a tabular model based on the calculate statement we just demoed. As we continue in the advanced features of the tabular model with Analysis Services 2014, we're now going to look at time intelligence. Time intelligence is one of the coolest features of using DAX and DAX functions. To-date functions like year-to-date, quarter-to-date, and month-to-date can be integrated into an Analysis Services tabular model. This helps centralize the business intelligence of a company's sales. But sales is not the only measure usable in these functions. Measures like count, distinct count, and ratios are all doable with analytical measures. The requirements are for a date dimension table to be flagged as date type. The column in the date table has to be unique throughout the rows of that table and is a date data type. There is no requirement for the year, quarter, or month like the cube to have special date type properties. The functions work on the date column itself. In addition to the to-date functions, you can also use previous period for year, month, or quarter. The period over period calculation will help display trends in your analytical data. The date table has to be assigned before any time intelligence is used. Once you have a date table in your model, select it and go to the table menu choice. From there, go to the date submenu, and there'll be an option to mark as date type. A prompt will come up to locate a date data type column in that table. It has to be unique throughout the whole table. Without a unique date data type column in the table, the to-date, previous period, and other time intelligence functions of DAX cannot be used. The year-to-date, quarter-to-date, and month-to-date functions are used to create a new measure. In this example, you can see that date key column of the date dimension used in that dates YTD DAX function. This is embedded in the calculate statement with the internet sales as an expression. Here is what it looks like in an Excel pivot table once you drill into the quarters of 2012. You will see a continuous increase in year-to-date sales for 2012 until the next year is displayed. The total for quarter 4 for 2012 is the same as the total for year 2012. This same function can be done for quarters as well as months. The previous period DAX function works the same way. Here we're using the same period last year DAX function in the calculate statement to get the internet sales from the previous year. This is a new measure. Here is what it looks like in an Excel pivot table once you drill into the quarters like the previous example. But now we have a third column that's previous year's internet sales. Here you can see the previous year alongside the current year to date. Now, a new measure can be created to compare this year's to-date values for sales with the previous year at that point in time sales. And this is a trend that can be graphed in Excel or other reporting tools. Now let's look at a demonstration of using time intelligence. First, we'll launch SQL Server Data Tools. Once Data Tools is launched, we're going to open up a previously created project that has most of our setup inside of the Internet Sales fact table. Once the solution is open and we go to the grid view, we want to go to the Internet Sales table. We'll scroll to the right to see the other measures that have been previously calculated. We'll just click in a blank row, and the first thing we'll do is we'll look at year-to-date sales. We're going to call this YTD Internet Sales. Semicolon equals, and then we'll start with the calculate function. Remember, this is a wrapper to help remove filters expressed in a measure while it's being sliced and diced. The first option is the expression. Here, we're going to pick Internet Sales. This is a previously created measure. We could put the sum of sales amount if we would like to. I'll put a comma and a space, and then we'll apply our first filter. Our first filter will be for year-to-date sales. This is going to be one of the DAX functions. We'll start with dates, and you'll see the month-to-date, quarter-to-date, as well as year-to-date. So here we can actually create three different measures for year-to-date sales, quarter-to-date sales, and month-to-date sales. We'll hit the tab key on YTD, and then it's going to ask us for that date data column that we talked about in the requirements. We'll start with a single quote to find our table, DA to find the date table, and we'll scroll down to the full date alternate key. That's the date column in our date dimension in this dimensional model. I'll hit the tab, close parentheses for the dates YTD function, and then another close parentheses for the calculate, and I'll hit the enter key. Here we'll notice it's not formatted, so we'll go to properties and change that to currency. Before we create any other measures, let's see what that looks like. We'll go to the model menu choice and we'll analyze in Excel. It's better to look at these things in Excel or a reporting tool because you can slice and dice different dimensions. We're going to click OK to use the current user, and once Excel comes up, we should have a pivot table ready. We'll select our year-to-date Internet Sales. Now, we see just one value, and that's because we don't have a date dimension attribute or hierarchy displayed. I'm going to scroll down in the pivot table fields to the date dimension and drag YQMD hierarchy to my rows. And now we see those values. But to verify that the value is correct, let's scroll up and we're going to put Internet Sales as another measure. And we'll make that the first value in our list. And here you could see year to date according to those. Now if we drill in to say year 2012, we see in quarter one the year to date sales is 1.375 million. And then in the second quarter, even though it's 1.3 million in sales, our year to date now is 2.69. So this looks like the calculation is performing correctly. Let's minimize Excel, go back to our model, and now we'll create the previous year, same period, previous year value. So we'll start with a name, previous year, year-to-date Internet Sales. We'll put a semicolon and an equal sign, and here we're going to start with the calculate statement. Our expression is Internet Sales again, but this time the function is going to be same period last year. And then we'll go grab that date column, date, full date alternate key, close parentheses for the same period last year function, as well as for calculate, and hit the enter key. We'll go to the properties and we'll change general to currency, And then let's go into the Excel and do a refresh all, and we'll see our new measure. It's misspelled, but that's okay for now. We'll click it and we'll see the values from the same period last year. If we drill into 2011, we'll see that the quarter was 1.4 million, and now if we go to 2012 and look at previous year-to-date sales, we'll see the 1.4 million there. That looks to be correct, so let's minimize this and create one last thing. First, I'll correct the spelling, but then we'll go to the next one, and we're going to look at the difference from last year, or let's say last year to date. Semicolon equals, and now we basically can get the year-to-date sales for this year minus the previous year-to-date sales. Hit the enter key, and we'll change the properties to currency again. We'll go ahead and make sure we save our work. If we go back into Excel and do a refresh all, we now should have another measure. Our previous year-to-date was renamed, and then our difference. And now we can see the difference between the current year and the previous year, and we can draw trends along that. In the next section, we're going to look at key performance indicators, which we can have indicators visually if sales are going up, down, or level. Next, in our advanced section of the tabular model, we'll look at KPIs, which are key performance indicators. These are an integrated tool that helps companies flag trends in their data. These metrics are important to business and helps find upward trends or an area that needs adjustment. The KPIs are defined in the data model of analysis services. They can be used in other area of reports that connect to this tabular database. The centralization of calculations and metrics enable a single source of information for reporting tools. An example like gross profit margin or comparing sales to a predefined sales quota are a great example of uses for KPIs, and this is the centralization of their value in the business. The indicators can range from streetlights to bars or even pies. They can have 3 possible goals or 5 goals. The numeric values to compare can be in a database or can be hard-coded in the model. The colors and indicators are completed in the tabular model to help one source for your reporting tools. Here's an example of a ratio. The gross profit margin created in a previous session in this module will be used as an example. The gross profit margin is a comparison of the sum of sales minus the total cost divided by that sum of sales. The profit margin is a typical metric for business. After creating this KPI, Excel is a great tool to see the results, or any other reporting tool. Displaying it in the tabular model will not give you the exact comparison you will need. Until you start to slice the dimension by the attributes or hierarchies, it's hard to see its significance. Let's look at a demonstration of creating a KPI. First, we'll start by launching SQL Server Data Tools. Once the application is launched, we'll open a previously created solution which has the project for our AdventureWorks Data Warehouse 2014 Tabular module. Once that is open, we'll stay in the grid view and we'll go to Internet Sales. We'll scroll to the right to see our gross profit margin. Overall, the gross profit margin is 41.15%. Let's look at this in Excel by going to Model and Analyze in Excel. Once we click OK for the current user, Excel will launch in a pivot table and we can display the gross profit margin. We'll scroll down till we get to the date and place that on the rows. In here we can see the gross profit margin for each year, which ranges from 40% to 55%. If we wanted to, we could add to the columns the product by category and get a better range of these values. Here we see accessories around 60, bikes around 40, clothing ranging from 32 to 42, and overall 40 to 55. So those numbers will base our KPI upper, lower, and middle range. We'll minimize Excel and right-click on our gross profit margin. Here we get an option called Create KPI. Once we click that, we'll get a window that helps us define our KPI. First, you'll notice in the Define Target, you're actually able to pick another measure to compare the gross profit margin to. This can be used when you're comparing actual sales to the sales quota for particular salespeople. But in our case, we're going to use an absolute value. Our absolute value is going to be a percent, so we have to put it as a decimal. We'll pick 0.41. And then when we tab out of that, we'll see that Analysis Services pick 0.2 and 0.3 for our upper and lower. We'll change the upper to 0.45 and we'll change the lower to 3.8. This gives us a range. Now we can choose the different icon styles. We can choose flags, the X and check, a set of street lights, as well as other options. There is actually an option for 5 target values with bars, cubes, and also pies. This lets you put 3 different levels of values. We'll stick to what we have selected and we'll click OK. Now we'll save our work and go back into Excel. In Excel now, we'll refresh all to pull in our new values and we'll show the field list. Now we'll see in the measures area, we have a separate section called KPIs. The KPI was created for gross profit margin. In here you see there's a value, a goal, and then a status. We'll take the goal off and we'll keep the status. Now if we look at our pivot table, we're going to see different values and different indicators. For some we have yellow, which is about on target. We have some that are red, which means below target, and then we have some that are above the target. Now, since there's a wide range in here, you would want to put this in your dimensional model as target values based on categories and or years. Categories would be a better way to pick this so you're not putting an absolute value in the tabular model.